In this assignment, you're asked to compute all common substrings of toStrings, which is actually an important problem in computer science. One often uses it when analyzing genes, for example, to find common subsequences. The algorithm that you're using here is not very efficient. There are far more efficient algorithms for doing this, but it's simple enough that you can program it fairly quickly. So you were in fact given a recipe for what to do. It says generate all substrings of the first word in the same order as they were used in a previous assignment. That's the assignment where I gave out this solution here. So if you look at this solution here, it generated all substrings in order, starting with the largest ones. Let's see if that was the same order we were supposed to be doing. Looks like, yeah, same order as last time. And so over here, where we used to print the substrings, now instead of printing them, we're supposed to be doing something with them. So what are we supposed to do? Let's first of all assign it to something. And then we're supposed to test whether they also occur in the second word. And we're supposed to find whether whether we've already reported it. So, and if they're not yet reported, then we're supposed to add them to an array. So the difference is that rather than printing them, we're now supposed to collect them in an array. So let's see how we do this. So, and I should say an array list. When you want to collect stuff, it's always much easier to collect it in an array list than an array, because we don't yet know how many there are. One could actually compute it in this case. There's a formula for the number of substrings of a string, but we're not doing that. We simply put them in an array list, and then whenever we found one, we call add, and that way the result array list just accumulates more and more of them. Eventually, we return that array list. This, by the way, is a very, very important pattern that you should be aware of. So over here, make an array list to hold the result, do a bunch of work, and whenever you found something, then you add it to that array list, and in the end you return. So this method here has a return value of an array list, and it just collects a bunch of answers. A very, very important and common task, that you want to collect a collection of answers, not just a single answer, but a bunch of them, and this is how you do it. So over here you see the same loop that we've just seen, and here you see the condition. The second string contains the first one, and over here I was cheating a little bit in a good way. So I've looked up that there is a contains method in the ArrayList class that checks whether the ArrayList already contains this element. If you didn't find that method, you would have probably had to use a second loop that makes the same determination. You can find out manually whether sub is contained in the result by going through all of the elements in there and trying to find it. There's an algorithm in the book for finding a match, and you could have implemented that algorithm. But of course it has been implemented for us in the standard library, and then it's perfectly fair to use it. In general, if you wonder whether it is fair to use a method from the standard library, just put a question on Piazza. Alright, so this is it, and it actually is a very economical thing. It's just a few extra lines over what you had to do in that previous homework assignment. Also notice that when you test this, the tester was a little bit different than what you'd seen before. The tester simply calls this method here with various arguments. So there's the code for reading any input is hidden from you. I will be using these kind of testers more and more, because putting something into a method and then calling that method with a bunch of test cases is of course a useful way of doing it.